In this video, we're going to talk a little bit about the derivative, very important object in Calculus 1, and in fact, it is the main focus of our study in Calculus 1. So suppose we want to find the slope of a tangent line to a curve at some point. Now we know that this is the formula for slope, y2 minus y1 over x2 minus x1. It's an algebra fact. So let's think about finding the slope of the tangent line here in red at the point x of f of x. So I can take 2 points on the curve nearby, so I can choose x itself. And I can also choose, let's go a little bit of distance in the x direction, or in the x direction here. And let's do x plus h for some number h, right? So h might be 1, 2, 5.5, 1.25, something like that. Just some number. So I move a little bit in the x direction in the amount of h. And now f of x plus h, if I look at my curve, is like here. So this would be f of x plus h. So I'll go ahead and label these here. This right here is going to be, oops. This is going to be f of x, and this is going to be my value f of x plus h. Okay, so I can draw a line between those 2 points and easily find the slope of it, because I know what those points are going to be. This is the point x, f of x, and this is the point x plus h, f of x plus h. So if I want to find the slope of that line, the purple line, m equals y2, which we'll take to be f of x plus h, minus y1, which is going to be f of x, over x2, which we'll take to be x plus h, minus x1, which is going to be x. So m equals f of x plus h minus f of x over these two x's in the denominator will cancel, and I'll be left with h. Now, notice that if I take that distance h and I shrink it, so I make it smaller, let's say this is my new x plus h, we'll call it x plus h1, and it's even closer to x, then my line that I'm taking into consideration here is this line. And let's say I even bring it even closer, let's say I bring it this close. Then notice that my line, as I bring this x plus h closer to x, approximates closer and closer my actual line, the red line that I'm looking for. I'm looking for that tangent line. And as I bring my x plus h closer to x, I get closer to that line. So in order to find the slope of the tangent line, our idea is taking the limit as h goes to 0 of x plus h, of this difference quotient, because that means that x plus h is going towards x. It's getting closer to that line. So that definition, so we'll say that the slope of the tangent line, so m tangent, is going to equal the limit as h goes to 0 of f of x plus h minus f of x over h. Cool. So this gives us the slope of that tangent line, the red line there. And we actually define the derivative in this way. So we say that the derivative is the slope of the tangent line. So the slope of the tangent line to the curve f at point x is defined to be, there's a couple different ways to write it. You may see it as d by dx of f of x. You may see it as f prime of x. You may even see it as, more rarely, df of x. But it's equal to the limit as h goes to 0 of f of x plus h minus f of x over h. And there's a couple different ways to formulate the difference quotient there, that limit, but they're all equivalent. So you might see it as f of, the limit is x goes to c of f of c minus f of x over x minus c, something like that. But this, we say that the derivative is this limit when it exists. So if it doesn't exist, we say that the derivative does not exist. So we need that limit to exist in order for our derivative to exist. Okay, and this is a function in its own right, this limit, and I'll denote it as interchangeably f prime or d by dx of f of x. Okay, and this d by dx notation, the idea behind the d by dx notation is the slope m equals delta y by delta x. And we can kind of think of taking h to 0 as making those deltas into a much smaller increment, we'll say d, and y equals f of x, so this is df by dx, or in other words, d by dx of f of x. Okay, that's kind of some intuition behind that. So let's work some problems. Let's find the slope of the line tangent to f of x equals x squared at x equals 1, and then we want to find the equation of the tangent line. So in order to find the derivative, we need to use the difference quotient. So my f of x is equal to x squared. So my f prime of x, we take the derivative first. We form the difference quotient and take the limit first, then we plug in later. Always take the derivative first, then plug in later. So this is going to be the limit as h goes to 0 of f of x plus h. So f of x plus h is x plus h squared. Notice it doesn't matter what I put inside f, it just gives me that same thing squared. So I could have easily had, like, I don't know, f of smiley face is going to equal smiley face squared, right? So x plus h, f of x plus h becomes f of x plus h becomes f of x plus h becomes x plus h squared. So I have x plus h squared minus x squared, which is f of x. Maybe I'll go ahead and rewrite the difference quotient here. So it's going to be f of x plus h minus f of x over h. That's our difference quotient. So you want to take the limit as h goes to 0, plugging things in. So f of x plus h was x plus h squared. So I have x plus h squared minus x squared over h. Okay? So I'm going to expand this using the formula. Let's write it out here. A plus b squared equals a squared plus 2ab plus b squared. If you don't know that, FOIL it. So we have x squared plus 2xh plus h squared minus x squared over h. This is going to be the limit as h goes to 0 of, so this x squared and this x squared will cancel, and I'll be left with 2xh plus h squared over h, which is, dividing off these h's, I have the limit as h goes to 0 of 2x plus h, which is just giving me 2x. Now, I want to find the derivative when x is equal to 1. So evaluating this when x is equal to 1 gives me 2 times 1, which is 2. And remember that this is the slope of the tangent line. Great. So we found our derivative, we found the slope of the tangent line. And the reason why we did all that algebra is because if you took h goes to 0 of this, you would get a indeterminate form, right? You would get in, so we need to do a little bit of algebra to calculate this limit as before. So what we need to do now is find the equation of the tangent line, and the fact that I'm going to use is that the line between 2 points can be written using the point slope formula. That is y minus y naught equals m times x minus x naught for a point x naught, y naught, and slope m. So we just found that our slope is 2, so we just need to find a point on the curve. We can use the point where x equals 1. So x equals 1 means that f of x equals f of 1, which is 1 squared, which is 1. So our point that we can use is x equals 1, f of x equals 1. And our slope, recall, is 2. So plugging this into our point slope formula, we have y minus y naught, which is 1, is equal to m, which we found is 2, times x minus x naught, which is 1. So we have y minus 1 equals 2x minus 2. Adding 1 to both sides, y is equal to 2x minus 1. Beautiful. That is the slope of the tangent line. Okay, moving on, we want to find the slope of the tangent line to f of x equals sine x at x equals pi over 3, and then find the equation of the tangent and normal line. So again, we want to form the difference quotient, where f of x plus h is sine x plus h, and f of x equals sine x. So we want to find f prime of x equals the limit as h goes to 0 of sine of x plus h minus sine x over h. So we're going to use the identity that sine of a plus b is equal to sine a cosine b minus cosine a, plus cosine a sine b. Okay, so we're going to use that fact, and we're going to split this sine x plus h up into, we got, hello? So sine x plus h under this formula here becomes the limit as h goes to 0. So we'll take x to be a and h to be b of, let's take sine of x times cosine of h plus sine of h cosine, that's fine. Sine of h cosine of x minus sine x over h. Okay, now we're going to do a little bit of factoring here. So we're going to split this up as the limit as h goes to 0 of, I can factor out a sine x from here and here, and I will have sine x times cosine h minus 1 plus sine h cosine x over h. This is going to be the same as the limit as h goes to 0 of sine x times, I can write this as negative 1 minus cosine of h over h plus cosine x times sine h over h. I did a lot in that one step, but I challenged the viewer to see how all of that makes sense. So I put a negative on this, dropped this outside, split up the sum here. I did a lot. I split up the sum like this into two separate summands here. Took this cosine, brought it out front, have sine h over h left over. And then in this term, I took sine h out front, and then I have cosine h minus 1 over h. Add a negative 1, I have 1 minus cosine h over h. Now, these guys are both trig limits, and we know that as I take the limit as x goes to 0, or sorry, as h goes to 0, this will give me 0, and this will give me 1. So what I actually have here is that f prime of x will equal sine x times 0 plus cosine x times 1, which means that f prime of x is cosine of x. Great. Now, I need to plug in x equals 3 to find my slope for my tangent line. So I need to evaluate at pi over 3. So f of f prime of pi over 3 equals cosine of pi over 3. Which is going to be 1/2. Great. Now, me double check that. Okay, great. So that's the slope of my tangent line. So my m tan equals 1/2. And then remember that the slope of my normal line is the negative reciprocal of the slope of my tangent line because they're perpendicular. So it's going to be -2. Okay? So that's important information for finding the slope or finding the normal and tangent line. So next you want to find the equations of the normal and the tangent line. So again, we're going to use the formula y minus y naught equals m times x minus x naught. So for my tangent, I can use the point pi over 3 f of pi over 3. So I need pi over 3 f of pi over 3, and f of x, remember, was just sine x, so that's pi over 3, and then sine pi over 3, which is pi over 3 root 3 over 2. Okay. Yes. Now I can plug everything in and have y minus root 3 over 2 equals m, which in this case was 1/2, that's the slope of my tangent, times x minus pi over 3. I can go ahead and just, I'm not going to do a bunch of simplification, I will just subtract that, or sorry, add that root 3 over 2 to both sides and distribute that 1/2 and get 1/2 x minus pi over 6 plus root 3 over 2, and I'm not going to fiddle with that anymore. Now for my normal line, I can use the same point, but I have to use the normal slope. So y minus the square root of 3 over 2 equals -2 times x minus pi over 3. That's going to give me, after doing everything, -2x plus 2 pi over 3 plus the square root of 3 over 2. Okay, so that's the equation of my normal and my tangent line. Okay. I have one last example that I want to do. We want to find the derivative of the square root of x at x equals 4. So we're just going to go ahead and go through this pretty quickly. So f prime of x, I challenge you to see why that this is going to be the limit as h goes to 0 of the square root of x plus h minus the square root of x over h. Should be pretty clear. Now the strategy for this is to multiply it by the conjugate. Now remember that the conjugate of the two terms with of a binomial with a square root is you just take the sign that's in the middle and you flip it. So I have x plus h plus the square root of x, square root of x plus h plus the square root of x. And what multiplying by the conjugate does for us is it gets rid of those square roots in the numerator. So applying the formula a plus b times a minus b gives us a squared minus b squared, a difference of perfect squares. So applying that to our case here, I have the limit as h goes to 0 of x plus h. The square root of x plus h squared is going to be x plus h, minus the square root of x squared is x, over h times the square root of x plus h plus square root of x. Right? Now this positive x will cancel with this negative x, and so I'm just left with h over h times all of this junk. These h's will cancel, and so now I'm left with the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. Now I can easily take the limit as h goes to 0, and that's going to give me 1 over the square root of x plus the square root of x, which means that the derivative of 1 over x is the square root, the derivative of the square root of x is 1 over 2 square roots of x. Great. And I want to evaluate that at x equals 4. So that is going to give me f prime of 4, which is 1 over 2 square root 4, which is 1 over 2 times 2, 1/4. Beautiful. Okay, that wraps up what I wanted to say about the limit definition of the derivative and kind of some intuition about the derivative. If you found this video helpful, please consider liking and subscribing. Thanks.